This is voltage regulator using IC317. This is IC317 and this is the diagram. Here you can see this is a transformer, this is a rectifier circuit, this is a filter circuit using capacitor. This is 3-pin IC317. This resistor R1 is fixed. Here we are using 100 ohm. This R2 we are varying from 0 to 1 kilo. And this is one more electrolytic capacitor. This connection is for current meter, and this is the load resistor. Here you can measure voltage across the load resistor. Now let's see the circuit according to that diagram. Here you can see this is the transformer. Here we are using only 15 volt. If you want to use 30 volt, then you have to insert between these two terminals. Then output of the transformer is given to bridge rectifier circuit. This is the bridge rectifier circuit. This is filter capacitor. Then output of the filter capacitor is given to pin number 3 of 317. This is the pin number 1, this is the pin number 2. In between pin number 1 and 2, 100 ohm resistor is connected. Then instead of this resistor of variable value, that is potentiometer of 1 kilo and this 10 kilo, here we have used 1 kilo resistor by constructing and connecting 10 100 ohm resistors in series. So 100 plus 100 plus 100, 10 times, that is the 1 kilo resistor, and this 1 kilo, 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 total 10, that is the 10 kilo. So in this circuit, instead of potentiometer, we have used 10 100 ohm resistors for constituting 1 kilo and 10 1 kilo for constituting 10 kilo. Here in between these two terminals you can connect current meter. Here you can see that these terminals are connected to ground. From here, this terminal and this terminal both are grounded. Then from pin number 2, this is the output. This output further goes to this point, and from here this is the positive terminal, and from this is the negative terminal. Now this crocodile pin you can connect to different resistors, and you can change the output voltage. At this juncture it is not connected to any resistor, hence it is showing 13.57. If you see this formula where V output is equal to V reference, which is fixed 1.25, inside the bracket R2 upon R1 plus 1, where R2 we are varying from 100 ohms to 1000 ohm, that is 1 kilo ohm, and R1 is fixed. When R2 is 1000 ohm, this should come approximately 13.75 volts. But since we have measured it 995 ohms, hence we are getting approximately 13.6 voltage. By switching off this power supply and connecting this digital multimeter as a resistance meter, you can measure value between this ground terminal and this terminal. Here you are seeing it is not exactly 1 kilo, hence we cannot expect output exactly as 13.75 volt. So let's see what different voltage we are getting when we are changing R2 from 0 to 1 kilo. Now let's disconnect this. Switch on again. You must remember that while measuring resistance, you must switch off the supply. Also, you must disconnect one terminal. Now this I am wearing here. When 0 ohm resistor is connected, you can see that value is 0.95. For 0 ohms, here it is 0.95. Calculated is 1.25 and difference is 0.3 voltage. See, this is 1 kilo and these are 10 kilo. Here you can see 1 kilo. Color code is brown, black, brown. Brown, black, brown, brown, black, brown. So 100 into 10 is equal to 1 kilo. And here brown, black, red means 1 kilo multiplied by 10 is equal to 10 kilo. So this is R2. We are wearing this. So for 100 ohms, here you are getting 2.45. For 100 ohms, here it is 2.5. Here you can see 100 plus 100 is 200. This is 3.68. Calculated is 3.75. Difference is 0.07. Now for 304.92, here it is showing 5. Difference is 0.08. Then change it. Here it is showing 6.15 for 400 ohms. Difference is 0.10. Then this terminal is 500, 7.4, 7.5. Difference is 0.10. This terminal is directly connected here with this black wire. Therefore here you will get same. Now come to this. For 600, it is showing 8.63. 8.75 calculated, it is 0.10. Slight 0.02 variation may be possible. Then in next, it is showing 9.86, that is 9.9. You can see 9.9. Calculated is 10. Difference is 0.1. Next, For 800 ohms it is showing 11.10, 800 11.10, 11.25 calculated. Then next for 900 12.33, then last 13.55 and calculator is 13.75. So this difference is because of plus minus 5% variation, and because of this variation due to tolerance, this value is exactly not 1 kilo ohm. That's why slight difference is possible. So this 317, by varying R2, you can get different voltages. If you want 5 voltage, then you have to keep this to 300 ohms. See, 4.92. If you want 10 voltage, then 7 means here 9.84, that is approximately equal to 10 voltage. So in this way you can construct variable voltage supply. This is regulator, means its output voltage keeps constant irrespective of the change in input voltage or change in output load current. Now we'll change the output load, means we'll change this 10 kilo and we'll see what happens to this voltage. It should remains constant, means for 1 kilo, if it is 13.57 or 13.55, whatever it may be, by varying from 1 kilo to 10 kilo, it should be 13.55. So let's see we are getting this or not. So for that we have to change this now in this direction, because 10 kilo is constituted by these 1 kilo resistors connected in series. Here I have connected this here. Means what is the resistor, load resistor? 1 kilo into 9 is 9 kilo. For that output is 13.55. Without this also, if nothing is connected, so I have removed this, it is showing 13.55. When I connect, it is showing 13.55. Now let's decrease. This is for 800. It is same 13.55. Now change it to 700. Again 13.55. Then 600, 13.55. Then 500. See, 500. Again 13.55. See, here also it is 13.55. Here also it is 13.55. Here also it is 13.54, 13.47, and last here you can see for 500 resistors 13.55, 13.55, then here also 13.55, 13.55, 13.55, 13.55, 13.55, 13.55, 13.55, here also 13.55, when there are only two resistors, that is 200 ohms. Now it is 13.54. For 100 ohms it is 13.54, and when it is connected here means it is 0, so obviously its value should be 0. So highest value is 13.55 and lowest value is you can get 13.54. Here you can see RL varies from 1 kilo to 100 ohms. For 1 kilo it is 13.55, for 100 ohms it is 13.54. So percentage load regulation you can find out by VNL minus VFL upon VNL. So 13.55 minus 13.44 upon 13.55, that comes 0.07. So this is the load regulation. If you want to find out the current, you can connect here in between these two another multimeter as a current meter. So let's connect this as a current meter. For 1000 it is showing 48 milliampere. Now let's decrease. Now it is for 900 ohms. You can see here for 900 ohms it is showing 47. Then for 800 it is 63. Then by decreasing resistors you can see the current goes on increasing. Then next reading it is 86. You can see here that voltage remains constant. Voltage is not changing, but as I am decreasing resistance, this is for 500. It is 103. There you can see now for this 400 it is 130. Then for 300 here I have reduced one more. I am repeating here again. You couldn't see, therefore I am repeating again. See here it is for 400 it is 130. For 300 it is 173. Now for 200, actually since it is about 200 milliampere and in this meter we cannot measure about 200 milliampere, therefore it is showing I infinity. So here you can conclude that as you decrease resistance, current goes on increasing, but this voltage remains constant. Continue the last part, that is line regulation. In line regulation we have connected this primary of the transformer to auto transformer or thermostat. In this auto transformer you can vary from 0 volt to 270 volt. Here we don't require current meter, therefore we have removed that current meter and directly connected these two connections. Here we have kept voltmeter. Now see, when it is 270 volt, it is showing 13.56. Now it is 260. Again you are seeing same voltage 13.56. I am decreasing this voltage in steps of 10. 13.56. Now it is 240. 13.56. it is 230, 13.56. You note down this special reading, that is 230 volt. In India, the power supply 230 volt is the normal voltage. This is 220 voltage. Again it is 13.56. This is 210, 13.56. 220, sorry, 200, again 13.56. This is 190, 13.56. You can see this is the arrow. 180, 13.56. Now 170. Now see here, now it is decreased 13 point. Again I am 3 turning it to maximum. Here you have seen 13.56. So in this you can see that for 270 it is 13.56. This remains constant. Only at here it is changed from 13.56 to 13.38. So in line regulation we can find out by 13.56 minus 13.38, 13.56 minus 13.38 upon the voltage at 230 volt, that is 13.56. So let's see after calculation what is the value. So here you got this 1.32 value. So this is the line regulation. So in this way you can do this experiment. Here you can see two same circuits. This is the one circuit and this is another circuit. Here only difference is that here you are seeing only one resistor. Here two parallel resistors are connected. Since 1 kilo resistors were not available, so two kilo resistors are connected in parallel. So when two equal value resistors are connected in parallel, their effective value is half. Hence this resultant value is 1 kilo. Now let's see how intermediate connection between three different circuits is made. Here all diodes cathodes are in upward direction. You can see all cathodes are in upward direction. This cathode anode combination goes to transformer. This cathode anode combination, this is anode and this one is cathode, combination goes to transformer. Cathode becomes positive terminal. This is given to positive terminal of this filter circuit, of this filter, capacitor filter. This is electrolytic capacitor filter, and this negative is connected to anode combination. Then this is connected in such a way that this heat sink is on the top side. Hence this is terminal number 3, which is the input terminal. This is the output terminal, and this one is the adjustment terminal. So in between adjustment and output terminal, this 100 ohm resistors is connected. This can be 200 ohms or 250 ohms. Then from this, here you are seeing that from the R1 and pin number 1 combination, this variable resistor, that is potentiometer, of 1 kilo is connected from R1 and adjacent. So here this is R1 and this adjacent terminal. This 1K total value is constituted by connecting 100 ohm resistor in series. Then from this output, that is pin number 2, this red you can see. Then other end is connected to 10 kilo resistors. 1 kilo, 1 kilo, 1 kilo, 1 kilo, 1 kilo is 10 kilo. So this is the output load resistor RL. So in this way you can connect the given circuit on tag board. That's all about this experiment.